everything else. So what is it? Now in the nucleus, it was found around 1911 that the nucleus is a very small, tiny region where proton, neutron are condensed, very high density if you go in terms of atoms. And the size is measured in unit. Nuclear size is measured in unit. What is that unit? Sorry?
Nuclear size, picometers.
There is a name. Okay, picometer. Fine. There is a name, Fermi. Unit is called Fermi. It is 10 power minus 13 centimeter minus 13 centimeter. And what is the size of atom? Normal? Angstrom. So what is the difference between Fermi and angstrom? 10 power 5. 100,000. Now you see the scale difference. If you plot on a piece of paper nucleus by pen or pencil on 1 millimeter, then what would be the size of the atom? 1 millimeter is the size of nucleus. What is the size of atom?
100 meters.
100 meter. So how much distance it will cover? Think of any space, this building, that building. So is atom empty? There are few electrons. Think of in terms of the Fermi. So they are spread and the atom is empty? No. What is there then?
Electrons there, field, electronic field are there.
So it means that if we compress the electron atom, distance will go on reducing. Okay. Why I am raising these questions? When you read these things, you hardly bother about it. You do not ask yourself that how to visualize these things. You cannot compress one atom. I don't know any experimental technique which has gone to that level. But if you take a gas or liquid or even a solid and have a piston, apply the pressure. If you have a gas, initially you can compress it easily. But as volume start decreasing, it becomes difficult, much more difficult. And with the machine available to you, you cannot compress further. Why? Why you cannot go on compressing? Because nucleus is of the order of 10 power minus 13 centimeter, and if you reduce all those things. And the second question is, why electron being negatively charged and nucleus positively charged, why all electrons do not fall from the nucleus? You know, electrostatics, you know, the positive and negative charge attract with each other. So what is the solution? So first let us try to see how the electron is distributed in the atom. Can anyone of you explain it? He is right, but he gives answer. That electron is not just a tiny, dimension of electron is much smaller than the proton, much smaller than the nucleus. So electron is not just a particle. electron is represented by wave. Proton it can also be. But if I ask you, say in this room, there are electrons and there are protons. Can you have some rough estimate the wave associated with electron and wave associated with proton, what would be the difference? Do you know how to understand, how to figure it out?
Main difference charges की
Sorry?
charges का main difference
आपने बोलो, आवाज में तुम्हें दिक्कत है ना? आप बोलो जोर से.
charges में main difference होंगे उनके wave function में protons and electrons.
Charge is playing the role. Mass.
Mass.
Mass is, do you know, okay, you call deep broadly, pronunciation is deep broad. It is a French name. So do you know deep broad formula?
Yes, lambda equals to h by
Lambda wavelength is equal to h by
momentum.
h by p. What is h?
Planck constant.
Planck's constant. Very good. You know that also that you remember. I'm not questioning your memory. What is p? Lambda is equal to h by p. Now, if I ask p is a scalar or vector,
Vector quantity.
you have learned it, your high school level, p is a vector quantity. So h by vector. What is lambda?
Vector.
Lambda is a vector.
Yes.
And wavelength is a vector. आप तालाब में कंकड़ी फेंको एक वेव बन गई. It is a vector quantity. These are the simple mistakes we make of it. It is the magnitude of the momentum. H by magnitude of momentum, which has no direction. Yeah, P is not velocity but speed. So m actually appears as under root. Yeah. When you convert P into the thermal energy mass, it converts into under root 2 pi m T K Boltzmann constant T. So wavelength associated with the particle is inversely proportional to under root mass and under root temperature. So mass electron being very small compared to 2000 times something like that. So electron wavelength associated with electron is much longer. And you have also, if you have already read quantum mechanics or not, if you are going to read it, so you know that if you try to compress the wave, then energy goes high. It is called quantum confinement. You put a particle in a box and try to reduce the volume, then energy associated with the particle goes higher and higher. So, you may read that you may hear someone saying that atom is a lot of empty space in atom. That is not true. It is the wave associated with electron which is occupying its space. And if you try to compress it, energy goes high. And why gas, when you are compressing it, it becomes difficult. Because atom, big neutral atom, I'm talking of neutral atoms, they interact with each other. And the interaction between these atoms, if the distance between these atoms is slightly more than their diameter, say diameter is 1 angstrom, Then 1.2, 1.3 distance is there, some gap is there. Then these atoms attract each other. And when these atoms start overlapping with each other, this electron or this electron, then Pauli exclusion, which I said that, Pauli exclusion come into play, and it causes an enormous energy. So they repel each other. You see how this plays. I am standing here. Newton's third law tells us, okay, I'm applying, my weight is applying a force on the surface of the earth. And gravity is there. So gravity should attract me to the center of earth. But it is not doing so. Why? Gravity is not able to do it. Why? Newton's third law can say I'm compressing the earth. Earth is applying opposite force. How Earth is applying opposite force? Earth knows only gravity. Earth attracts anything which comes close to it. So where come this opposite forces above it? If some younger sister or brother asks these questions to you, you are undergraduate or graduate study, and suppose your younger brother and sister is in high school or plus school later, ask this question, what would you answer? You want to ask such silly question? That is we teacher often do.
So surface. Surface.
So how this reaction created? What is the mechanism? We are talking in terms of atom. One exclusion. You cannot compress the electrons of the atoms. So they bounce you back. So it is the electromagnetic field. Gravity is pulling us toward the center, but atoms on the surface of it, they are getting compressed by my weight, and they are applying the Pauli exclusion principle to repel my atoms of this. Now the next level comes in. Okay. If you were doing science, let us take some lessons from what people have done. This thing was a question, why a gas, say, steam, water, gas or water, when you cool it, let us keep the pressure same, you cool it, then the temperature called critical temperature. If temperature goes below that, then it becomes water, liquid. And if you come to 0 degrees Celsius, then it makes ice. Ice is a crystal. And crystal is a very particular lattice structure. Particular structure. So why gas, by simply cooling it becomes water and it becomes ice. Okay. These are the observations of time people they are doing. There was a person, his name is Wonderwalls. You might have heard his name. Wonderwall. Equation of the state. By these things he conjecture, it is a conjecture, no way of knowing it. He conjecture that there must be attraction between the molecules. that is why they come. As you lower the temperature, they come, kinetic energy start decreasing and they come closer and closer with each other. An attractive force starts playing a role between them, and they come start living together on the condense. They get condensed. Water is. But there must also be repulsion between them because you cannot compress it beyond a limit. As you start compressing it, more and more force is needed. So there must be some repulsion. From what was the observations? Now this is developing the concept. These are deduction. You deduce something from some observation. Ancient people were much smarter than we are because we rely more on printed and published literature. So using this, that there are repulsion, there is attraction, he wrote repulsion of the state, and he explained how that converts into reality. He did not explain every step, but he explained. And people still saying it there, van der Waals theory.